Okay, so this is our first lesson in this unit on energy types, and we're going to talk about mechanical energy first. So, mechanical energy. If you've ever ridden your bike, you know a lot about this stuff already, actually. So, let's get started. Mechanical energy is both potential and kinetic energy together. So, we're going to see what these look like very soon, right? We're going to take a look at this picture after we learn more about these types of energy. So mechanical energy is both potential and kinetic. Well, what is kinetic energy? Kinetic energy, you see this guy speeding down a hill on a bike? Kinetic energy is just the energy within moving objects. So this person moving really fast on a bike, or like a train that cannot stop. Okay, so this train has a lot of kinetic energy. The brakes aren't able to stop it before it hits that truck. This person knew the train couldn't stop because it has a lot of kinetic energy. Luckily, they were able to get out of the way. But this is probably the dumbest thing I've ever seen. Lastly, lots of kinetic energy. Here comes a different truck. Okay. Energy is arrested. This bridge has to stop the truck, and that's why it would be a pretty terrible ride right here. So kinetic energy is energy within moving objects. I use trains because they have so much. Okay, but potential energy is just energy stored within an object. So these two together make mechanical energy, and there are different types of potential energy, as we're about to see. The first type, the type we'll come back to again and again, is the type of energy this rock has as it's sitting at the top of the cliff. It's not moving, it's not kinetic energy, it's potential. But if this rock fell, it could certainly do a lot of damage. It has a lot of energy in it. The type of energy this rock has is gravitational potential energy. Okay. So anything that can fall has gravitational potential energy. It's energy that gravity can release as something falls. So in a moment here, we're going to take a look at that picture up at the top of the page. Here we go. So this picture at the top of your notes, here you have a cart. You can think of it like somebody riding a bicycle, and they're at the bottom of the hill and they're going very fast. They have a lot of kinetic energy. If you've ever been at the bottom of a hill and you sped up so you could get up the hill more easily, you're giving yourself more kinetic energy. You get to the top of the hill, maybe you're tired, and you stop. Okay? You don't have any kinetic energy at all, but you do have potential energy. So that potential energy is stored within you. If you've ever gone down a hill on a bike, though, you know how fast you can get going. Well, what's happening is that this potential energy converts back into kinetic energy. So the energy types can be transferred from one to another, and that's the first example we'll come up with is somebody riding up to the top of a hill, turning their kinetic energy into potential energy, and then flowing back down a hill, back in from potential to kinetic energy. So because mechanical energy is both potential and kinetic energy together, the mechanical energy, no matter where you are on this hill, is staying the same. It just happens to be kinetic energy here, gets up to potential energy when it's here, but then back to kinetic energy as it falls back down the other side. So the mechanical energy stays the same, even though it's switching between the two. Okay? Well, that is gravitational potential energy. Chemical potential energy is something else. Okay? I've got a picture of somebody flexing a muscle and a battery here. Now, chemical potential energy is what you're doing when you eat. You need energy to live. You're getting that energy from the chemicals inside of your food. Primarily like sugar type things, carbon. Here's what the notes say. Energy stored in chemical bonds. As you eat, you're taking in this chemical potential energy, and your body then breaks those bonds apart. So you eat lots of carbon and hydrogen. You inhale oxygen, which is used to burn it. You exhale carbon dioxide, which is the waste product. So that carbon is your food being exhaled. if you lose 100 pounds, if you're those people who, diet for 5 years and lose 100 pounds, they exhaled that weight. It came out as carbon dioxide. Okay? So that's chemical potential energy. Last one is elastic potential energy. For example, a bow and arrow. If you pull the string on a bow, you're bending these arms a little bit, and that bend, that energy is stored in the bent arms until you release the string and it straightens out again. Okay? Elastic potential energy is energy stored by deforming objects. Just like a rubber band. If you pull a rubber band, you're storing energy inside of it. So all of this covers mechanical energy. Okay? But there are other types of energy something can have. Okay? So, mechanical energy covered. Now, let's also talk about thermal and radiant energy. As we go through the next units, we're going to see that thermal and radiant show up again. Thermal energy is simply heat energy. So the energy something has because it's hot, because those atoms are moving really, really fast. On the other hand, radiant energy is energy that's released in electromagnetic waves. We've learned about these in the past. So this is an infrared camera showing this part of his hand is hotter than the part right here. This is an example of a thermal camera demonstration. So that person, his hand warmed up that part of the wall, and now the wall is giving off a little bit more thermal heat. Okay. Now, normally you wouldn't be able to tell which mug is hot and which is cold. This one's got probably ice water in it. This one's got hot coffee or something. Well, this is cool. Takes a sip from the hot cup. Tongue's hotter. When he took a sip from the cold cup, his tongue was colder. So every person who's warm is radiating this energy away. So your face is radiating lots of energy away. If you cover your face, if you cover more of your skin, you feel warmer because you're saving that energy up. You're reflecting it back. You're not losing it quite so easily. So you can see that his clothes look cooler than this. Okay? Well, the things that we're looking at here, this is infrared light, which we've talked about many times before. So that's radiant energy. You're radiating heat away. If you've ever been near a stove that's on high, you can feel that heat radiate and hit you. Same with a campfire. Your front gets warm and your back stays cold until you turn around. Electrical energy, we're all familiar with. Electrical energy, the flowing of electrons, usually through metal, but, in some cases, like lightning, it flows right through the air. Electrons are being transferred from the ground up to the sky, and that's electricity right there. That's as hot as the sun, just for a nanosecond. Okay. One type of energy we don't cover today is sound energy, but lightning is a great source of sound energy in the form of thunder. The last type of energy we'll talk about is nuclear or atomic energy. Okay? Energy that is released by joining or breaking apart atoms. Okay? So if you take atoms and break them apart, that is called fission. Okay? And that's this picture here. If you wanted to label it fission, this is a reminder if you're interested, this is fission. You're breaking apart this atom into two different types of atoms, and you're getting a lot of energy from that. So there's fission. Over here, what we have is atoms that are being joined together through fusion. So we take a hydrogen and a hydrogen, fuse them together, and we get a helium, but that also releases lots of energy. If you're interested, keep listening. Fission only releases energy when it's large atoms being broken apart. So you see this is a huge atom, 235 protons being broken apart, whereas fusion releases lots and lots of energy when it's small atoms being put together. So you take a hydrogen and a hydrogen, put them together, helium, you get even more energy. And that's the end of our notes.